A very good morning, dear students. Whatever we derived in the last videos, that using the derivations, using that formulas, now we are going to solve some problems on step up chopper. First problem. For a step up chopper, a DC chopper has an input voltage of 200 volts and load of 8 ohms resistance. The voltage drop across thyristor is 2 volts and the chopper frequency is 800 Hz. The duty cycle is zero point 0.4. Find average output voltage, RMS output voltage and chopper efficiency. So, whatever the problem also, first you write down the given data. So what is the given data? They given the source voltage is 200 volts and load resistance R is equal to 8 ohms and voltage drop V drop is 2 volts and also chopper frequency F is equal to 800 Hz and duty cycle delta is equal to zero point 0.4. This is the given data, and then we need to whatever the unknown parameters, we need to find. The first is V naught average, VRMS and chopper efficiency. So for finding V naught average, what is the formula? So already we derived. This is the step of chopper. Already they given the statement given in the question. So for step of chopper, what is the V naught average? Vs divided by 1 minus delta. So Vs minus, why we need to take V drop means in the question they gave as a drop. We have the drop. So if they are mentioning V drop, some voltage means always wherever we are writing Vs, we need to subtract it. So Vs minus V drop divided by 1 minus delta. So that is now before going to simplify, Vs new is equal to Vs minus V drop. So that is 200 minus 2 volts, that is 198 volts. Now I am going to substitute my V new value 198 divided by 1 minus 0 0.4, that is 330 volts. So V naught average is 330 volts. We know V naught RMS. If we know, we can write it, otherwise we will derive it once again. V naught RMS is equal to square root of 1 by t into integration 0 to delta t V naught square of t into dt. So now V naught square is nothing but a Vs square dt. Vs square constant, we can take it out from the integration. So Vs square by t into integration of 1 dt. You know, integration of 1 is nothing but a t, because we are doing with respect to dt. So that is integration of 1 is t. So t with limits is t minus delta t. Okay. Now Vs square by t into t minus delta t. So you can take it t common, t of 1 minus delta. This t it will get cancelled. So Vs square, I am going to take it out from the square root. We'll get it as a Vs into square root of 1 minus delta. Now we can substitute what is our new Vs, because whenever we are going to substitute Vs, we need to consider only the Vs new. Why means in this problem they get given as a some drop in the source voltage. So only we should not consider the original Vs. So the Vs new is 198 into square root of 1 minus 0 0.4, that is 153.37 volts. So that is V naught RMS is 153.37. Next, last unknown parameter is chopper efficiency. Chopper efficiency is output power divided by input power. So output power we are going to calculate as a P naught is equal to 1 by T into integration delta T V naught square by R into dt. So V naught square is nothing but a Vs minus V drop square by R integration delta T dt. So Vs square, anyway this is you can take it out. Now with limits is integration of 1, you know what we did in the previous step. So integration of 1 is t minus delta t. If you substitute limits, the t it will get cancelled, and then Vs minus V drop square into 1 minus delta divided by R. This is P naught. Next same thing, Ps is nothing but a Vs. Here the input Vs is same, output only we are going to substitute as Vs minus V drop. So if you simplify this one, we'll get it as the efficiency is Vs minus V drop by Vs. We can substitute Vs minus V drop is 198 divided by 200, we got 0.99. That is efficiency is 99%. Because of this 2% drop, we got 99%. If there is no drop, we'll get here 100%. Okay, clear? We'll see another problem. The buck regulator shown in figure has an input voltage of 12 volts. The required average output voltage is 5 volts at R is equal to 500 ohms and peak to peak ripple voltage is 25 kilohertz. The peak to peak ripple current of inductor is 0.8 amperes. Find the duty cycle L and C. This is the circuit diagram they given in the problem. Always what I told in the first step, we need to write the given data, then only it is easy to solve it. Okay, the given data, what is the given data? The source voltage is 12 volts and output voltage V0 is nothing but a 5 volts, and resistor is 500 volts, and frequency is 500 hertz. So from that we'll get the T value. And one more is nothing but a peak to peak ripple current. Delta I is to delta delta I is delta V is 200 millivolts. Delta L is 2, ripple current is 0.8, ripple current is 0.8 amperes. Okay, and also they gave in the question, by mistake I didn't write even peak to peak ripple voltage. This is peak to peak ripple voltage, also they gave 20 milliamperes. Okay, this is the given data. Okay, now we need to find out, the first one is nothing but a duty cycle. So if you want to find the duty cycle, we need to assume V naught average. There only we have duty. V naught average is Vs into delta. Here delta is nothing but a V naught average divided by Vs. V naught average already we know, 5 divided by del Vs is 12. We got 0.416. Okay, next we need to find out that L and I value. So if you want to find L and Y value, we need to assume, we need to consider our peak to peak ripple current, because there only we have L and I value. So the peak to peak ripple current is delta I is equal to delta into Vs into 1 minus delta by Fl. So there I am writing as a L value. If you can substitute, we'll get it as a 145 microhenries. To find our capacitor value, we need to assume our peak to peak ripple voltage. Peak to peak ripple voltage is delta Vc is equal to delta I divided by 8 into Fc. So delta I already we know, delta I is, you know, now C is nothing but a delta I divided by 8F into delta Vc. You can substitute everything, we'll get it as a capacitor is 200 microfarads. Like this we can do the so many problems. So now this is one more problem. Input to the step up chopper is 200 volts. The output required is 600 volts. If the conduction time of the thyristor is 200 microseconds, find the chopper efficiency. The pulse width is half of the pulse width is halved for the constant frequency of operation. Find the new output voltage. So V is equal to 200 volts, T on is equal to 200 microseconds, VDC is equal to 600 volts. VDC is equal to V into T, you know, V into T divided by V into delta, that is T divided by T minus T on. 600 is equal to 200 into T divided by T minus T on is this one. Now if you solve this one, we'll get the T value is 300 microseconds. The chopper frequency F is equal to 1 by T. We got already frequency. If we substitute 1 divided by 300, we'll get it as a chopper frequency. The pulse width is T on is nothing but a 200 microseconds. Here already they get 200 microseconds divided by half of that one. We'll get it as a 10 seconds. So now the frequency is constant, so output voltage is nothing but a output V into T divided by T minus T. So we'll get it as a 300 volts. So like this we can do so many problems. I hope you understood. Thank you all.